A brand new type of wave power plant has been floating off the coast of Cyprus for 2 years now, and in the future it could produce electricity that's said to be even cheaper than solar and wind energy. We're talking about the Wave Line Magnet, a wave power plant from sea wave energy, and the company promises electricity that could cost just 1 cent per kilowatt hour. We will look at how the new wave power plant is supposed to work and whether this finally marks the breakthrough of waves as an energy source. And with that, welcome to the German Science Guy. I'm Dr. Beautemps, and in Germany we say Los geht's. Whether it's solar, wind or hydroelectric power, when it comes to generating electricity from renewable sources, we've actually come a long way. But one massive energy source remains virtually untapped to this day: the ocean. In addition to tidal power plants, waves also hold an incredible potential. They alone could generate 29,500 terawatt-hours of energy per year. That would simply cover the entire world's electricity needs. There's also a major advantage. While wind and solar energy fluctuate due to the weather conditions, waves could truly provide a constant power supply, especially since the patterns can be predicted relatively well. Plus, in winter, wave power can be up to 4 times higher than in summer. Wave power plants could therefore perfectly complement solar power plants in particular. The research on wave power plants has been ongoing since the 1970s, so there really are various prototypes ranging from buoys to giant sea snakes, and yet no technology has really made it into commercial use. But now there's a new type of wave power plant with a completely different approach, the Wave Line Magnet. At their core, wave power plants are designed to convert the mechanical energy of waves into electrical energy. Most systems consist of 2 components: a movable part that interacts directly with the waves and a fixed part, for example one anchored to the seabed. Nevertheless, there are various types of wave power plants. These differ based on how they interact with the waves, where they are located in the water and how far they are from the coast. Listing all of them would definitely go way beyond the scope of this video, but if you would like to see an extra video on some of these topics, feel free to leave a comment. A fundamental mechanism in most wave power plants, however, is Archimedes' principle. This describes the buoyancy of an object underwater, whether it floats, sinks or hovers in the water. For example, there are buoys that float in the water and are moved up and down by wave pressure, thereby generating electricity. The Wave Line Magnet also makes use of this Archimedean principle. However, unlike buoys, for example, the system does not submerge. The device therefore moves with the wave rather than fighting against it. The system looks a bit like a snake moving across a wave. The company itself describes this principle as neutral displacement theory, essentially an extension of the Archimedes principle. According to the company, this results in one major advantage. The Wave Line Magnet does not need to be shut down during storms, but actually benefits from adverse conditions. As a result, the wave power plant is said to be up to 10 times more efficient than other methods. Sea Wave Energy states a single one of its wave power plants could, under perfect conditions, achieve an output of more than 100 megawatts. Just to put that in perspective, currently an offshore wind turbine generates around 15 megawatts. We'll discuss later whether the claims about the Wave Line Magnet are truly realistic in the big hurdle of this video. But first, let's have a closer look at the new system. As mentioned, the system moves with the wave. This means that energy is generated with every rise and fall of the wave. To make this work, the Wave Line Magnet has a modular design. The current system consists of 20 individual platforms. The entire system is made up of 4 parts. The most important part is a spine. The spine connects all the parts together, including the platforms. This is a part that lies directly on the sea surface and moves with the waves. Accordingly, the platforms are also the part that transmits the movements, specifically via levers directly to the spine. And from there to the final part of the module, the PTO system, or Power Takeoff System. This activates a pump that draws in seawater and pressurizes it. This pressure can then be used to drive a generator. This way, the mechanical energy of the waves is converted into electricity that can be fed into the grid, for example via undersea cables. The PTO system is therefore a central component of the Wave Line Magnet. and it can be dynamically adapted to conditions in the sea so that maximum energy can be extracted from the waves. And that's also super important because the system doesn't always behave the same way. Some modules produce the most electricity with short waves, others with longer waves, depending on where the platforms are located within the wave line converter. And if the waves come too quickly one after another or are too high, the system must be slowed down so that it doesn't move too violent. So this is how the waveline magnet actually works. Thanks to its modular design, the waveline magnet is highly adaptable to all kinds of conditions. The startup promises that its system can withstand even extreme weather conditions and adapt to almost any wave. If the wave power plant is truly as flexible as the company promises, it could indeed be deployed anywhere. This has one major advantage. It can not only generate electricity, but thanks to the high pressure inside the modules, also desalinate seawater. According to the company, this would allow electricity and clean seawater to be delivered even to fairly remote locations. And that's not all. The wave power plant is said to be relatively inexpensive to manufacture. The company relies on recycled plastic and synthetic materials, in other words, readily available materials. This naturally makes the system relatively sustainable and lightweight. And because there are already so many systems to work with these materials, no new infrastructure would be needed for production, which automatically saves a significant amount of money. Mass production would therefore theoretically be possible without major obstacles. Maintenance costs are also expected to be relatively low. This is always a major point of criticism with other wave power plants, since they require divers, for example. With a waveline magnet, all mechanical components are located directly at the sea surface. This makes them comparatively easy to access, eliminating the need for diving teams or other complex maintenance equipment. The CEO of Seawave Energy is actually making even more promises. He says once a system can be built and installed on a commercial scale, the levelized cost of electricity is expected to be just 1 cent per kilowatt hour, which is crazy. That's not only significantly less than other wave power plants, which currently cost just under 72 cents per kilowatt hour. If the costs were really that low, the waveline magnet could easily outpace PV and solar. As you might remember from one of my last videos where I visited the biggest solar park in the world, there they had a super cheap energy production of just 1.6 cents per kilowatt hour, which is still more than 1 cent, but still super impressive. Well, you also have to say the solar park is already there and in operation, so this might be a little bit more promising, but just as a side note, and if you haven't watched this video, make sure to watch it after this one. It's my most complex and expensive video I ever did so far, and I would be super happy if many people watch it. But let's first take a critical look at the wave power plant, the big hurdle, the part in every of my videos where I look at the limitations of an innovation, because even the best innovation has some hurdles. And as always, I put all my sources in the video description so you have maximum transparency. If you like this, you can support it for free by subscribing to this channel and activating the bell. Okay, so it all sounds pretty good to me. Still, so far, there are only prototypes of the waveline magnet. They have already been tested in the ocean over the last 5 years, but after that test, there was not so much buzz anymore. 2.5 years ago, there was another press release stating that the company planned to launch the next pilot test at the sea. But since then, we haven't really heard much about the wave power plant, which is interesting because I became aware of the topic precisely because it was in the news a lot again. But that aside, I already discussed the biggest problems with the wave power plant. The ocean is simply an extremely challenging environment for power generation. While there is this huge theoretical potential, storms, corrosion due to the salt water, and the impact on the environment and wildlife repeatedly lead to problems. And I know the startup says, oh no, we don't have these problems because our system is better, but you have to trust them, right? According to the company, storms and corrosion are no longer an issue with their product. The company even claims that the power plant will last up to 50 years, but whether that's really true can't be proven right now, and that's exactly what I want to emphasize again here. Most of the information about the waveline magnet actually comes from the company itself. There's exactly one study that has examined the technology behind it. But even that study contains no independent data on the capacity or the targeted levelized cost of electricity. And at this point, again, the reminder, I'm always transparent about my sources. You can see them here and then find them in the video description if you want to check it yourself. But now for me the big question was, where do the 100 megawatt promises come from? The reality looks quite different right now. The 32 meter long, 1.8 ton prototype achieved just 1.4 kilowatt. Yes, kilowatt, not megawatt, in the test tank. So really far below 100 megawatt. To achieve such capacities, the waveline magnet would have to be quite heavy and huge. And that could then bring other challenges in terms of transport, installation, and also maintenance. So at first glance, the waveline magnet sounds like a revolution in the field of wave power plants. 100 megawatt, 1 cent per kilowatt hour, stormproof, but after 5 years of prototypes and now silence, I'm pretty skeptical. C-Wave Energy is still in the startup phase and has been looking for partners for the next steps for several years now, and I do find the technology behind it exciting, but the promises seem a bit too ambitious to me, and because I saw it so often in the media, I wanted to make a video about it, having a critical look at it. But what do you think about these promises? Do you think they can be reality? I'm really curious about your thoughts in the comments, and there's a video about a river power plant from Germany that is already in operation, and with independent studies you can check it out. And also this video is the biggest video I ever made about the biggest single-sited solar park in the world. Please really check it out, and I say auf Wiedersehen, which means goodbye in German. See you next time, your Jacob.